Hello once again. Today we are going to touch on the last of our subtopics under this topic, energy, work, and power. Now the last topic we're going to deal with is power. So far we've seen that energy is the ability to do work. A body can only do work if it has energy. We've also talked about the several types of energy. We tried calculating potential energy, where PE is equal to mass times gravity times height. And then we also got to calculate KE, kinetic energy. Then we found that to be half times the mass times the square of the velocity. Now, velocity is here because kinetic energy is only possessed by moving objects. If velocity is equal to 0, that means the object is at rest, so there will be no kinetic energy, but instead there could be potential energy. We went on to work, and then we got to see that work is done whenever a force is applied to move an object through a certain distance in the direction of the force. So when we apply force and then the object does not move, we are doing nothing. Work is also equal to energy transferred or energy transformed. So if an object is at a height, it has potential energy. Once it begins to fall, it starts to do work because the potential energy will be changed to kinetic energy. So the potential energy being changed to kinetic energy is the work done in this case. Now let's move on to power. Different engines, big or small, can do the same amount of work. Different engines can do the same amount of work, but it is the time in which the engines do the work that matters, and that is what we call power. A smaller engine like this motorcycle can do work. It can apply force through a certain distance. It can pull a cart, for example. It can apply force through a certain distance. Okay, but the time in which the work is done determines the power of the engine. A truck can lift huge containers. The same applies to motorcycles. A motorcycle can pull a huge container, but the time in which it can cover that distance will differ immensely from the time in which this can also pull the container, and that is what we call power. So time taken in which work is done may differ. Generally, bigger engines do work faster than smaller engines, and then they can lift greater forces, or they can apply greater forces. This means bigger engines take smaller time to do work, but smaller engines take longer times to do the same amount of work. The rate at which work is done is what we call power, as I stated earlier.